Hi everybody, this is Mrs. Mondragon, and I am here to talk about chapter 4.6 notes, which is about the isosceles and equilateral triangles, their properties, and the angles inside of them. I want to first talk about some definitions. So I want to focus on the legs of an isosceles triangle. The legs are these on this picture are AB and AC, and those legs are the congruent sides of an isosceles triangle. The vertex angle is the angle formed by the two legs. And in this picture, that vertex angle is up here. It's angle A. And then the base angles are the congruent angles that are opposite of the legs. And what I mean by opposite of the legs is that across from AB is angle C. That's opposite. Across from side AC is angle B. So those base angles are always congruent, and they are opposite of those congruent legs. Now that we know those definitions, let's talk a little bit about what the base angles theorem says. So the base angles theorem says that if side AB is congruent to side AC, then angle B is congruent to angle C. Now the converse of that base angles theorem is also true. So if these two sides are congruent, then their opposite angles are also congruent. And the converse being true says that if the angles are congruent, then the sides are also congruent. Okay, so in this first example, you'll see that we have an isosceles triangle here, right here at GHK. And you guys can see that 50 is that vertex angle because it's where those two legs meet. So if the vertex angle is up there, then you should see that there are base angles at G and at K. Now, we don't know what those base angles are, but we do know that those base angles have to be congruent. And we can figure out what the sum of those base angles is if we subtract 50 from 180. So what I'm going to do is I'm going to take 180 minus 50, and that gives me 130. Oops, 130. Okay, next, I'm going to take that 130, and I'm going to divide it by 2. And that's going to give me 65 in this case. And so the measure of angle G is going to be 65 degrees, and the measure of angle K is going to be 65 degrees. Let's see if we can do this. The measure of angle G is 65 alt 01760. Nope, it didn't do it. Alt 0176. Ha! Look at that, I made a degree sign. Okay. Next, they're asking us about the measure of angle GKH. Oh, that's this one right here that's congruent to angle G. So maybe I can't copy it, but I'm going to type it again. So 65 alt 0176. Huh, look at that. All right, and I learned how to make that degree symbol. All right, next they're asking us about the measure of angle J. Now, you have to sort of figure out that you've got a whole different isosceles triangle here. So if you look here from H to J, or to K to J, you've got a different isosceles triangle. And you have these two different congruent sides. Now we already know, and bear with me, now my handwriting is a little bit sketchy. We already know that this angle here is 65 degrees, okay? And we know that this right here, these two angles form a linear pair, right? This is, oh, it's not a very big straight line, but that is a straight line right there. It's a linear pair. So if this is 65, then to figure out what this one is, what this angle is, the vertex of this other isosceles triangle, we would take 180 and subtract that 65, which would be 115 degrees. Okay. Oh, we can actually put that in there now, right? Nope. Not yet. Okay, so if we know that the vertex angle is 165 and we know that the two base angles have to be congruent, then we can do a little bit more math and figure out what those two base angles would be. I'm going to do the same thing as I did over here, and I'm going to start with the premise that the whole triangle is 180 degrees. And so I'm going to take 180 minus, I don't know why this is yellow. I wonder if I can change it. 180 minus 115, so that's 65, right? And then I'm going to take 65 and divide that by 2, 32.5. And so each of these angles, angle KHJ and angle J, should be 32.5 degrees. Alt 0176. Huh, I'm so excited about that shortcut. All right, and then the other one that they asked us for is the measure of angle GHJ. GHJ. Oh, that's both of these angles here. So hang on a second. Let's make sure we all know what we're talking about here. That is, oh, change the color on me again. That is this angle right here that includes both the 50 and the 32.5. So the measure of angle GHJ is actually 50 plus 32.5, so 82.5, alt 0176. Huh, that's so amazing. Okay. So those are all the angles on those two isosceles triangles. I want you to notice first that we have two congruent base angles. Because there are two congruent base angles, I then have two congruent sides that are opposite each of those base angles. So because of that, I can set up an equation to solve for x. Let's go ahead and do that now. Let's keep it in red. All right, so I can say x plus 3 equals 2x plus 1. All right, and of course I would simplify and do my algebra, and I would get to the point where I could say that x equals 2. Okay, now that I know that x equals 2, I'm going to take that answer and I'm going to plug it in right here, and I'm going to plug it in right here. Okay, so what I end up with is 2 plus 3 gives me 5. So this side of the triangle is 5 centimeters. Oh, okay, and then I'm going to do it again over here. 2 times 2 is 4 plus 1. That's also 5 centimeters. Okay, so when I'm looking for the perimeter of this triangle, all I have to do is add around the outside. So 5 plus 6 gives me a perimeter of 16 centimeters. All right, well, that's it for the sides. Now let's talk about these angles. All right, now I already know that B is congruent to C. So right away, before we do much else, I'm going to see if I can change the color here. And we are going to type in what the measure of angle C is. The measure of angle C is going to be 53, alt 0176, is going to be 53 degrees. Okay, now to find the measure of angle A, that's that vertex angle there, I'm going to have to do some thinking, right? So what I know is that both angles are 53 degrees, and whatever's left is going to help all three of those angles add to 180, right? So maybe if I started with 180 as my premise, right? All angles in the triangle add to 180, and I take away the two angles that I know. So 53 and 53 is 106. Then I'm left with 74 degrees. Oh, I think that's it, you guys. All right, so the measure of angle A is 74, alt 0176.